Okay, so for chapter 3 and 4, I'm going to be doing my explanation on item 6. So part A says, on a winter day, a child of mass 25 kg slides on a horizontal sidewalk covered in ice. Initially, she is moving at 3 meters per second, but due to friction, she comes to a halt in 2.25 meters. What is the magnitude of the constant friction force that acts on her as she slides? Okay, so we know that the mass is equal to 25 kgs. We know that the initial velocity is 3 meters per second. And we know the distance traveled, or the displacement, is 2.25 meters. And there are no other extra forces that are acting upon the child. There's only friction that slows the child until she stops. And so friction is doing work, and work is force times distance, and that work is exactly what removes the child's kinetic energy. So basically it cancels each other out. So we can set work done by friction equal to the initial kinetic energy. So that would be work done is equal to force times distance, and kinetic energy is equal to half mass times initial velocity squared. So we can set these formulas equal to each other. So it'll be FD is equal to half mass velocity squared. And we only need to find the force, or the friction force to be exact. So we can rearrange this formula to make the force the main component. So that would be, the force is equal to half mass times velocity squared divided by the distance. So since we already have all of these components, we can just go ahead and plug these in. And if you use a calculator, that should give you exactly 50 newtons. So the friction force is equal to 50 newtons. Okay, so for part B, it says, an airliner of mass 1.70 times 10 to the power 5 kg lands at a speed of 75 meters per second. As it travels along the runway, the combined effects of air resistance, friction from the tires, and reverse thrust from the engine produce a constant force of 2.90 times 10 to the power 5 newtons, opposite to the airliner's motion. What distance along the runway does the airliner travel before coming to a halt? Okay, so in this one, even though there are multiple forces acting upon the airliner, it's all been combined to produce a constant force of 2.90 times 10 to the power 5. So let's write down everything we know first. So we know that the mass is equal to 1.70 times 10 to the power 5 kgs. We know that the initial velocity is 75 meters per second. And we know that the opposing forces all combined together make up 2.90 times 10 to the power 5 newtons. And so basically, using the same reasoning we used for part A, we're going to use that. Instead of finding the force, since we already know it, we're going to find the distance. So let's use the same formula, and this time we will make the distance the main component. So it should be this. So we can just plug everything that we know. We know the mass is 1.70 times 10 to the power 5, and we know the initial velocity of 75, and we square that and then divide that by the force. And that put into the calculator should give approximately 1.65 kilometers, which is equal to 1,650 meters. Now for part C, it says a truck of mass 2.40 times 10 to the power 3 kgs is moving at 25 meters per second. When the driver applies the brakes, the truck comes to a stop after traveling 48 meters. How much time is required for the truck to stop? Okay, so first let's write down everything we know. We know that the initial velocity is 25 meters per second. We know that the distance that was traveled was 48 meters, and we know that the final velocity is 0. So here we want to know how much time it will take for the truck to stop, and we aren't given any forces. So we can use the kinematics equation, which should be velocity squared is equal to initial velocity squared plus 2 times acceleration times distance. So we can use this formula to find the acceleration, and after finding the acceleration, since we know the initial velocity and the final velocity, we can just use v is equal to v plus a times t to find the time. So let's do this part first. Let's rearrange this to be so that the acceleration's the main component. Since this is 0, we can just ignore that, and that should be equal to basically 0 squared is equal to 25 squared plus 2a, 48. And we can just rearrange this to make the acceleration the main component, and that'll be a is equal to negative 25 squared over 2 times 48, and that gives us negative 6.51 meters second squared. And now that we know the acceleration, we can find the time. And so let's rearrange this formula. It should give us t is equal to v minus initial v over a. And so that's 0 minus 25.0 over negative 6.51. And that should give approximately 3.84 seconds. So that's our time. Now for part D, it says, what is the magnitude of the truck's constant acceleration as it slows down? So we already found the constant acceleration, which is in part C, which is negative 6.51. But in this question, it's asking us just the magnitude, not the direction, and the negative sign indicates a direction. So the answer in this case would be a is equal to absolute negative 6.51, and that's just 6.51 meters per second square. So yeah, it's just because they were asking the magnitude and not the direction. And for part E, it says, what is the magnitude of the constant braking force that acts on the truck as it slows down? So We already know the acceleration now, so we can just use Newton's second law, which is just force is equal to mass times acceleration. And so our mass was, our mass was 2.40 times 10 to the power 3 kgs, and our acceleration is equal to 6.51 meters per second squared. And so if you just times them together, that should give us approximately 1.56 times 10 to the power 4 newtons. Now for part F, it says a car of mass 1.15 times 10 to the power 3 kgs is stalled on a horizontal road. You and your friends give the car a constant forward horizontal push. There is friction between the car and the road. Determine the directions of the 4 external forces that act on the car as you and your friends push it. You can regard the combined push from you and your friends as a single force. Okay, so we have a mass, or the car, which is 1.15 times 10 to the power 3 kgs. And so we need to find the 4 different forces that are being applied to this mass right here. So we know that there's always going to be a gravitational pull towards the earth, so that will be our downward force, is just the gravitational pull. And then since the car is on a surface on the road, there's definitely going to be a normal force as well that is pushing from above, and so that will be our upward force. And then we have the push force that me and my friend are applying to the car, so that is our horizontally right push, or the force that's being pushed along the push. And then there's the friction force that's going this way, and that's the force that's going opposite to the push. So the answers are basically the weight of the car is directed vertically downwards, and the normal force is directed vertically upwards. The applied force is directed horizontally along the push, and the friction force is directed horizontally opposite to the push. So that's basically the explanation for part F. And then for part G, our final part, it says the combined force that you and your friends exert has a magnitude of 8 times 10 to the power 2 newtons, and starting from rest, the car reaches a speed of 1.4 meters per second after you have pushed it 5 meters. Find the magnitude of the constant friction force that acts on the car. Okay, so we know that the push force is equal to, or the force that my friends and I are exerting is equal to 8 times 10 to the power 2 newtons. And we know that the velocity is 1.4 meters per second, and we know the distance traveled is 5 meters. So since the push and the friction forces are the only horizontal forces, we can basically do what we did in part A and part B and set the work equal to the change in the kinetic energy. And this time we're gonna do the net work, which is, or we're gonna write down the net work since we're trying to find the friction force. So, and we have the push force. So that would be the force push minus the force friction times distance. So this is still force times distance, which is the formula for work, but it's the net work. So that's why we're writing it down like that. And that is equal to the change in kinetic energy, which is half mass times velocity squared. And since we're trying to find the friction and we want to make that the main component, we can just rearrange the formula, and it should be friction is equal to force push minus half mv squared over the distance. And so we can just plug everything that we already know. And so friction is equal to 8 times 10 to the power 2 is basically 800. So 800 minus 0.5, which is half, times 1.15 times 10 to the power 3 times 1.40 squared over 5, and that is equal to basically 575 newtons. And so that is our friction force. And yeah, that's all the parts of